You guys ever heard of complex numbers?
No.
Never?
Sure.
Well,
Yes.
okay. Well, yeah, I was just wondering. There's not a right or wrong answer. I was just wondering. Yes, no? Sounds like no. Alright. An imaginary number that we call I, we put it italicized, fancy I, is a complex number whose square root is -1. So I is the square root of -1. Okay? So if we squared I, kind of like it says here, just like the square root squared, I squared is -1. Okay? So I is the square root of -1, I squared is -1. So like before when we were taking square roots of negative numbers, we can now do that. We just pull out the square root of a negative and call it I. Okay? So for example, they talk about the square root of -5 here. Well, the square root of -5 is just square root of -1 and 5. So I can pull out that square root of -1 and say I square roots of 5. Okay? Does that kind of make sense? Pretty much when you pull out a negative from your square root, you just put I out front.
So you basically just take out a -1 out of every place.
Yep. Okay. So like this example down here, the square root of -2 is something times the square root of 2. What's that something? I, yeah. I got rid of the -1 part, so I pulled out an I. Okay, does that kind of make sense?
Okay, so just turn positive, you put an I in front of it.
Yeah. Because the I itself is negative. It's the negative square root. Because we want to be able to simplify the stuff inside, but we can't do that with negative. So with I, we can simplify the stuff.
So basically, you use the I to turn the negative into a positive.
Kind of, yeah. Okay, so this next one, I have the square root of -3. If I pull out an I, so I pull out a square root of -1, what's left for the inside of the square root?
3.
3. Positive 3. Okay. Now we gotta do the whole thing. If I have the square root of -6, that's a negative, so I know for sure I can pull out I. And then I have the square root of what left? 6. Good. Okay. Last one. If the solution I get is I square roots of 8, what should I have started with? -8. Look at that. That's not too bad, right?
Not yet.
Not yet. Okay, the cool thing about, you guys love when I say that, about this is that I can now simplify the square root of 8, whereas before I couldn't because it was negative. Okay, I think we've talked about before how to simplify this. 8 is 4 times 2, yes? So when I pull out the square root of 4, just like before, it became 2, right? Well, this time I still have an I, so I say 2I squared root of 2. So when we have stuff in the square root that we can simplify, we still want to do that.
How did you get the 2 at home? Because I know how you got the 2 from the square root of 4, but you just add it to the top.
So 4 times 2 is 8, right? Then the square root of 4 is 2, so you pull it outside. Because you don't want the square root. You always want your square root as simple as possible. Okay, other questions so far? Okay. So how could I write the square root of -12? What's the first thing I would say? I square root of 12. Okay, well, can I simplify 12 with a perfect square?
Yeah.
What?
4 times 3.
4 times 3. So I have my I still outside, square root of 4 times 3. And which one's the perfect square?
4.
4, so what should I pull out?
2.
2, because the square root of 4 we said was perfect, which is 2. So 2I square root of 3. Because the square root of 4 is 2, so pull as much out as we can.
So it's just we're done. You have to leave another 2 in there or no?
Another 2?
Yeah.
Nope, because we got the 4 out, So the only thing that's left inside is 3.
Okay.
Because the whole square root of 4 came out, which is 2. That makes sense. Okay. Questions on that one? Okay, this next one. What's the first thing I would say if I have the square root of negative 25? Pull out an I, so I have I square root of 25. Well, it's the square root of 25.
Alright.
5. So I can now turn this into 5I. I can pull the whole thing is square root of 25, which is 5. I can pull all that out, so I no longer have a square root. Well, technically I have the square root of negative 1, but it just looks prettier, doesn't it? Fancy little I? No?
Yeah.
Yeah. What can I do with C? Pull out an I, so I have I, then what? Root 7.
No.
Can I do anything with that? No. That's all I can do. Okay, what about this last one, D?
Take out I and then 25.
Take out I, so I have I square root 50. Then what, Maddie?
Take out 25 and 2. Take out 50.
50 becomes 25 times 2.
And then take out 5 out of 25.
25 is our perfect square, so I can pull 5 out. So 5 I square root 2. Kinda, sorta.
Yeah.
Not too bad.
Not too bad.
Easy.
Not yet.
Easy.
Feel
This way.
Alright.
Are we really putting graphs in this?
Yeah. Promise it's not bad. You just can't overthink it. Promise me that, Maddie. Just don't overthink it.
That's a joke.
Okay. We're talking about complex numbers. Like before, when we have imaginary. We write them with a plus bi. So a is like a real number, like 1, 2, 3, 4, or negatives. The b times I is the imaginary part. It's the imaginary part because it's attached to the I. Okay? So if my b is 0, this whole thing goes away, so I should have a real number, right? If my a is 0, I just have an imaginary part. So that's kind of all this is saying. Is that if I have my b 0, it's a real number. So technically we could write all numbers like this. Like if I wanted to say 3, I could say 3 plus 0i. But that's too complicated, so we don't say that. Okay. On to some fun stuff. Like I said, we're going to graph with these. We change our axes, and I'm used to the x-axis, y-axis. We change it to the real axis and the imaginary. So real is our x, imaginary is going to become our y. Okay, so instead of x and y, we have real and imaginary. When it comes to graphing them, you graph it just like you normally would. Okay? So if I have the point, or the number, 3 minus 2i, the real part is the stuff not attached to I. So that'd be 3. Then the thing attached to I is negative 2, right? So all that is
So
the point 3, negative 2, yeah. And then just like before, you graph the point 3, negative 2. So right 3 down 2 is where you put your dot. Except for the only thing that's different is that instead of minus 2, it says minus 2i. That's the only thing that's different. But you still go left, right, depending on positive, negative, and up, down to positive, depending on positive and negative. Okay, does that kind of make sense? Then we can talk about the absolute value of a complex number. Well, it's just kind of like how you would find the distance before. If I go right 3 and down 2, I can use this fancy thing, Pythagorean theorem, distance equation, whatever you want to call it, to find how far it is from our origin. Okay? So you guys remember the Pythagorean theorem? A squared plus B squared is equals C squared. So if this is 3, what's 3 squared? What'd you just say?
3 squared is 9.
I thought you said 1. This is negative 2. What's negative 2 squared?
4.
4. 9 plus 4 is 13. Square root it. That is our absolute value of our complex number. This is a fancy little equation for the Pythagorean theorem.
Where did you get the 9 plus 4?
Say what?
Where did you get the 9 plus 4?
Because we are right 3, and 3 squared is 9. And then we're down 2. Negative 2 squared is 4.
And then you get that 13.
By adding. And then when we talk about Pythagorean theorem, remember to find this, you have to square root. Okay, so kind of all stuff that you've done, geometry, algebra 1, it just has this little I thing behind it. Okay. So this first thing says, what are the graph and absolute value of 5 minus I? Well, first, let's make a point out of it. My real part is the number, the 5, and if there's nothing there, just like before, what is it?
0.
0 and 1. There's
1.
nothing there, it's like a 1. Okay, and we have a minus sign, so this is like 5, negative 1. Okay, does that make sense? Just take the real number part and the complex part. So now to graph it, all you do, over 5, down 1. That's it. Okay, to find the absolute value, let's use a triangle. I know I'm right 5, down 1. So Pythagorean theorem, a squared plus b squared equals c squared. My a would be 5. What's 5 squared? 25. My b would be negative 1. What's negative 1 squared? 1. What's 25 plus 1? What do I do with the squared thing? How do I get rid of it? Square root. So your absolute value is the square root of 26. What we did here is exactly what that says. Take your real part square, add it to your imaginary part square. Okay. Questions there? Okay. Got kind of cut off, but what's going to be my coordinates of this next one? Negative 3, positive 4 or negative 4? Negative 4. So we got that minus there. Okay. So how do I graph that? Left 3, down 4, yeah. So that's the point, negative 3 minus 4i. That's its point. These are its coordinates. Okay. Let's use the formula this time to figure out our absolute value. I have the square root of, what should I put in for a? Negative 3. So negative 3 squared plus what should I put in for b? Negative 4. Well, it is negative 3 squared. 9. What's negative 4 squared? What's square root of 9 plus 3? What's 9 plus 16? 25. What happens? Square root it. And my absolute value is 5. You guys remember doing distance problems like that? No. Okay. Questions with that stuff? Not too bad, right? No? What's that face?
What?
You're giving me like this. It's terrible. Look. Okay. Even easier is this next stuff. Talk about adding and subtracting complex numbers. Okay? Just out of curiosity, anybody have an idea what we might do when we add and subtract?
Shit. But
Just take numbers and less numbers.
Oh, shit. First numbers and the last numbers go together. So what you're saying, Hayden, is that I take these two and add them. So 7 plus -3, which is how much? 4. And then you're saying I take -2i plus I, and I get how much I? -1i, or -i. So my number is 4 minus I. Take the real part, add or subtract. Take the imaginary part, add or subtract. Okay, let's do a subtraction one. My real numbers are 1 and 3. What do I do to them? Subtract. What's 1 minus 3? -2. What happens when I do my imaginary part? I have to add because I have a minus, and I get what? 7i. Questions?
no, this is pretty easy.
That's not too bad for day one, right? Completely new stuff. No, there's not a catch.
No, it's okay.